Hi, sir. This is T. Kushi from IDA, and my roll number is 37. And my topic for Tech Talk for COA subject is a unique microprocessor instruction set. What is an instruction set? An instruction set is a group of commands for a central processing unit in machine language. The term can refer to all possible instructions for a CPU or a subset of instructions to enhance its performance in certain situations. All CPUs have instruction sets that enable commands directing the CPU to switch the irrelevant transistors. The instructions tell the CPU to perform tasks. Some instructions are simple read, write, and move commands that direct data to different hardware elements. So generally, instructions are nothing but these instruction sets helps in enabling and directing CPUs in the form of commands. These commands help to switch the relevant transistors. The instructions are made up of a specific number of bits. For instance, the CPU's instructions might be 8 bits. So, as you all know, 1 byte is equal to 8 bits, where the first 4 bits make up the operation code or OP code that tells the computer what to do. The next 4 bits are the operand, which tells the computer the data that should be used. And the length of an instruction set can vary from as few as 4 bits to many hundreds of bits. Different instructions in some instruction set architectures have different lengths, and instruction sets architectures have fixed length instructions. So, what are some of the types of instructions? So, the first one is complex instruction set computers. So, complex instruction set computers are the processors that have an additional microcode or microprogramming layer where instructions act as small programs. Programmable instructions are stored in fast memory and can be updated. More instructions are included in computer instructions sets that in other types of instruction sets. A single instruction can initiate multiple actions by the computer, such as single add command launching multiple memory accesses, such as load and storage instructions, is one of the example. Next one is reduced instruction set computer. So, reduced instruction set computer architecture has hardwired control. It does not require microcode, but has a greater base instruction set. Reduced instruction set computer also uses a smaller and more compact instruction set with a fixed instruction format. Reduced instruction set computer processors are designed to process faster and in a more efficient manner. So the next one is enhancement instruction sets. These instruction types are more familiar because they're often used in marketing CPUs. For example, let us go back to the 166 MHz Intel Pentium multimedia instructor. So it was introduced in 1996 and marketed with the enhanced Intel CPU multimedia performance. So MMX refers to the extended instruction set. So, why are these instruction sets needed? Why are they important? What are the advantages of having these instruction sets? So, the ISA is fundamental for building fast, efficient computers that optimize memory and processing resources. It specifies the following supported capabilities such as instructions, data types, processor registers, main memory hardware, input output model, and addressing nodes. Instruction sets work with other important parts of computers such as compilers and interpreters. Those components translate high level programming code into a machine code that a processor can understand. Think of the ISA as a programmer's gateway into the inner workings of a computer. It is essential when working with application development, assembly languages, and compilers. It sets the rules for the hardware and software interface and defines what the CPU does and ensures its compatibility. How are instruction set codes used or how are instruction commands used? The first one is it is used for data handling and memory management. Instruction set commands are used when setting a register to a specific value or copying data from the memory to a register or vice versa, and for reading and writing data. Coming to arithmetic logic operations, these commands include addition, subtraction, multiplication, comparison, division, so which examines values in two registers to see if one is greater or lesser than the other. Next usage of instruction set commands is control flow activities. One example is branch, which instructs the systems to go to another location and executes commands there. Another one is jump, which moves to a specific memory location or address. What is instruction set in 8085 microprocessor? A binary command that is used to perform a function in the microprocessor over provided data is known as instruction. A set of instructions is known as an instruction set that decides the microprocessor function. Every instruction includes two main parts like OP code or operation code and the operand, where OP code or operation code is used to specify the function to be executed and operand gives the data to be functioned on. So here is the classification of instruction set of 8085. So instruction set of 8085 is further divided into 5 transfer instructions or 5 instruction sets, that is data transfer instruction set, arithmetic instruction set, logical instruction set, branching instruction set, and control instruction set. Here is a flow chart in which you will know what are all needed for this instruction set. As you all know, ALU means arithmetic logic unit, status register, adder, shifter, temporary register, accumulator, internal CPU bus. So this is a flowchart where you can know how the conditions takes place in an instruction set, how is the flow of the instructions and all. So let us know about these different types of instruction sets. The first one is data transfer instruction set. An instruction that is used to transfer the data from one register to another is known as data transfer instruction. So the data transfer can be done from the source to destination without changing the source contents. Data transfer mainly occurs from one register to another register or from one memory location to register or register to memory and between input-output devices and accumulators. Following are the list of data transfer instructions. Move, it is used to copy the byte or a word from the provided source to the provided destination. P push, it is used to put a word at the top of the stack. Pop, used to get a word from the top of the stack to the provided location. Push A, used to put all registers into the stack. Pop A, used to get words from the stack to all registers. XCHG, it is used to exchange the data from two locations. XLay, it is used to translate a byte in AL using a table in the memory. Instructions for input and output port transfer. So it is used to read a byte or a word from the provided port to the accumulator. Out, it is used to send out a byte or a word from the accumulator to the provided port. Instructions to transfer the address. LEA, it is used to load the address of operand into the provided register. LDS, it is used to load DS register and other provided registers from the memory. LES, it is used to load ES register and other provided registers from the memory. So here E is nothing but carry byte or carry bit, anything is okay. Instructions to transfer flag registers. As you all know, flags are nothing but flip-flops, that is 0 or 1. So LAHF, it is used to load AH with the low byte of the flag register. SAHF, it is used to store a register to a low byte of the flag register. Push F, used to copy the flag register at the top of the stack. Pop F, it is used to copy a word at the top of the stack to the flag register. So let us now learn about arithmetic instruction set. These instruction sets are used to perform arithmetic operations like additions, subtractions, multiplications, divisions, etc. So instructions to perform additions. add, used to add the provided byte to byte or word to word data. ADC, it is used to add with carry. Increment, it is used to increment the provided data or a byte by 1. AAA, used to adjust ASCII after addition. DAA, it is used to adjust the decimals after the addition or subtraction operation. Instructions to perform subtraction. So, sub is used to subtract the byte from byte or word from word. SBB, used to perform subtraction with borrow. DEC, used to decrement the provided byte or word by 1. NPG, it is used to negate each byte of the provided data, byte or word and add ones or twos complement. CMP, it is used to compare two provided data. AAS, used to adjust ASCII codes after subtraction. DAS, it is used to adjust decimals after subtraction. Instructions to perform multiplication. MUL, it is used to multiply unsigned data. IMUL, it is used to multiply signed byte by byte or word by word. AAM, it is used to adjust ASCII codes after the multiplication. Instructions to perform division. DIV, as you all know, it is used to divide the unsigned word by byte or unsigned double word by word. IDIV, it is used to divide the signed word by byte or signed double word by byte. AAD, used to adjust ASCII codes after division. CBW, it is used to fill the upper byte of the word with the copies of signed byte of the lower bytes. CWD, it is used to fill the upper word of the double word with the signed byte of the lower word. So instructions to perform logical operations. As you all know, logical operations are nothing but gates, and gate, or gate, NOR gate, XOR gate. So NOR, it is used to invert each byte of a byte, each bit of a byte or a word, and it is used for adding each bit in a byte or a word with the corresponding bit in another byte or a word. Or it is used to multiply each bit in a byte or a word with the corresponding bit in another byte or word. XOR, it is used to perform exclusive or operation over each bit in a byte or a word with the corresponding bit in another byte or word. Coming to test, it is used to add operands to update flags without affecting the operands. So iteration control instructions. So these instructions are used to execute the given instructions for number of times. So as you all know from the word iterations itself, you will understand that iterations are nothing but loops, and you can run the same programs n number of times until it is met to a stopping condition. So looping statements such as for loop, while loop, do while, these are all iterative statements. Loop. It is used to loop a group of instructions until the condition satisfies, that is Cx is equal to 0. Loop E or loop Z, it is used to loop a group of instructions till it satisfies Zf is equal to 1 and Cx is equal to 0. Loop NE, loop NZ, it is used to loop a group of instructions till it satisfies Zf is equal to 0 and Cx is equal to 0. JCXZ, it is used to jump to the provided address if Cx is equal to 0. And the next one is branching instruction set. So these instructions are used to transfer or branch the instructions during an execution. It includes the following instructions, that is call, used to call a procedure and save their return addresses to the stack. Ret, it is used to return from the procedure to the main program. And jump, it is used to jump the provided address to proceed to the next instruction. So thank you all. Hope you all understood about the instructions and different types of instruction sets, and about 8085 microprocessor instruction set. Thank you so much.